you all today to Dr. Adamkiewicz. Dr. Adamkiewicz is Associate Professor of Environmental Health and Exposure Disparities at the Harvard T.H. Chan School of Public Health. Personally, I tend to be inspired by people who move through life with the desire to answer questions. They tend to be the ones willing to travel down those unclear paths, explore new territories, appreciate the pit stops, and build new vistas. We call them pioneers, well, we used to call them pioneers. Dr. Adamkiewicz's question is, why does place matter? With a motivation to alleviate environmental health disparities. So his work is substantial. It's multifaceted as well. So he works with housing-related exposure disparities. The questions that he wants to answer there would be, for example, poor housing conditions can be associated with poor health outcomes, but these risks cannot be alleviated without understanding the mechanisms that shape exposures. What are the social, physiological, and behavioral vulnerabilities that may amplify the health effects associated with these exposures? He also works with evidence-based interventions. What mix of interventions from engineering to policy improve health and well-being? What are the benefits? Do we see reductions in exposures? Do we see improved health? And then finally, healthy urbanization. What are some of the challenges encountered when creating health and sustainable cities, both locally and globally? So in addition to his remarkable research career, which you'll learn a lot more about today, he's a very remarkable person. When I was a doctoral student, he always made time to meet when he was really busy. He always had a smile and encouraging words up with my spirits, and he continues to tolerate my bad jokes. In short, we need more of him in academia.
That's mutual, the bad jokes.
So whether or not you plan to be environmentally focused as epidemiologists, it's my hope that you leave here today with today's talk with like a new or deeper way of thinking about things. So I'd like to present you to Dr. Adamkiewicz.
Thank you, Erica. It's really a pleasure to be here. Thank you so much for the invitation to be here. We can make this as informal as you like. So if something is confusing, raise a hand. I tend to be long-winded, so maybe somebody should give me, if I haven't noticed the time by like 10 to the hour, just flag me down. So today we're going to be talking about some work that I've led looking at environmental issues within public housing, specifically within the city of Boston. Let's see if this works now. Okay. So I want everyone to take a deep breath and exhale. Okay. So the good news is that's brought some oxygen to your body, which is a good thing. The bad news is that it also brought some pollutants to your lungs. And even though this seems like a very clean space, urban areas are full of environmental pollutants that can be hazardous to your health. We spend approximately 90% of our time indoors. That means 9 of 10 human breaths that are drawn actually happen indoors. So that makes these environments important microenvironments to understand and to study. You know, even outdoor air pollution, which we talk a lot about in terms of having health effects, most people experience outdoor air pollution indoors. So it finds its way from outdoors to indoors and can really escape filtration that a lot of buildings like this have. So I want to talk today about a story relating to how housing can affect your health. I'd like to start with this paper. This was published back in 2019. A close colleague of mine, Diana Hernandez at Columbia, wrote this great paper called Housing as a Determinant of Health Equity, a Conceptual Model. And in this paper, she broke down the aspects of housing that are important for health. And she called them the 4 C's: cost, conditions, consistency, and context. So cost, housing affordability can affect your health. Being under constant stress of being evicted, having to move frequently due to housing costs, all of that can be relevant for your health. Today, we're going to talk a lot about conditions. Consistency also matters. Your ability to be residentially stable can be an important stressor in your life, and context matters. What's happening in the neighborhood around your home? But I'm going to spend most of my time today talking about the second C, conditions. When you look at a space like this, I'm constantly looking at the environmental influences that a space like this could have on your health. I'm thinking about the pollutants from outdoor traffic that find their way indoors. I'm thinking about the chemicals that can be emitted from furnishings. There are chemicals in the cushions that you're sitting on. There are chemicals associated with the carpet that we're standing on. So all of these factors can contribute to your environmental exposure and ultimately to your health. So these are two questions. Erica mentioned, why does place matter? These are really two of the key questions I try to ask and answer in my group. Why does place matter, and how can we eliminate health disparities? We know that genes and environment both shape health, but in terms of environment, there are lots of different environmental exposures that can be important for health: diet, environmental exposures, housing, physical activity, occupation, neighborhood, psychosocial stress, healthcare. All of these things shape your environmental exposures day to day. And these can be environmental stressors, physical stressors, or they can be social stressors. The other thing to recognize is that disparities in any of these environmental exposures can shape disparities in health. We know that health disparities are an important issue locally and globally. Sorry, dry mouth. And some of the reason for those health disparities can be disparities in environmental exposures. So let's unpack this a little more. If you think about our setting, like I said, 90% of our time we're spending indoors. The first place people often look for neighborhood level exposures that can impact your health is ambient conditions. Are you living next to a busy road? Are you living next to industry? Are you living next to an important industrial source of air pollution? Modifiers. So the building that you're spending time in can be a modifier of your exposure to outdoor air pollution. This room, you can hear the ventilation system going. This room has air that's supplied and recirculated and filtered that's coming into this space. So you're not being exposed to exactly the same levels of air pollution that exist outside this window. It's some lower number. Some estimates put it at 50% of the levels outdoors find their way indoors if you're conditioning it and filtering it in this way. Also, human activity matters. So whether you're in this space interacting with sources of air pollution at home, this could be using air fresheners and cleaning supplies. It could be cooking. It could be smoking. It could be using candles and incense. Lots of different environmental exposures that exist within the home environment. And then indoors, what are those sources? As I started to mention those, started to list those, what are those sources indoors that can be really important for shaping indoor air pollution? Indoor air pollution levels can be up to 5 times or more higher than outdoor air pollution because of this list of sources that I started to mention indoors. But I'm going to spend most of my time today talking about those factors in indoor environments that can shape your environmental exposures and your health. Over the last 40 years, we've actually learned a lot about environmental exposures in the home, and these images represent those exposures. So everything from secondhand smoke, I mentioned chemicals associated with carpeting, a gas stove. I mean, most people don't think of a gas stove as being a polluting device, but it's actually one of the few sources of combustion that emits directly into the space you're living. It's not exhausted to the outside the way a lot of other combustion byproducts find their way. Outdoor air pollution finds its way indoors. Cooking is an issue. Mold and moisture can be an issue in many urban settings. Pest problems. We work with a lot of households where they have significant cockroach infestation or mouse infestation. That can affect health. Pesticides, personal care products. Think about all of the chemicals that you can see in a kitchen cabinet or a bathroom cabinet. All those things can find their way into the air and ultimately into your lung. If you look at the specific exposures associated with all these, it turns into quite a lengthy laundry list. But the good news is we've actually learned a lot about each one of these exposures over the past 40 years, enough that we could actually control them if we were paying attention to them and actually trying to mitigate these exposures indoors. In terms of disparities, most of the evidence shows that low SES, low socioeconomic status households are more likely to have higher exposures of most of these indoor pollutants. There are a couple of examples of high SES households having higher exposures, but usually those are exposures that are associated with single family homes. So if you live in a single family home, you're more likely to be exposed to radon. You're also more likely to be exposed to volatile organic compounds from an attached garage. But in most cases, the evidence shows that low-income households, low-income families are more highly exposed to many of these things we care about. There is a group of modern chemicals. I know some folks in this department study endocrine disrupting chemicals, EDCs. Those are in a category called SVOCs. Those are semi-volatile organic compounds. Whether it's skewed high income or low income really depends on the product there. If you're talking about personal care products, many of those products are more likely to be purchased by high income households. If you're talking about things like pesticides, which are a part of this group of semi-volatile organic compounds, you're more likely to see those in lower income households. So much of my work looks at environmental exposures through a disparity lens, trying to understand which populations are more highly exposed or less exposed than others. The one thing to pay attention to with indoor air exposures is that a lot of these exposures are nested. So we're sitting right now in a room, in a building, in a neighborhood. And what you're actually exposed to sitting in this room and breathing the air in this room depends on what factors are at play at each of those levels. So the household sits within the building, sits within the neighborhood. If someone's smoking in a household, that's going to be a direct exposure to occupants of that apartment or that dwelling. If you're not smoking in your unit, but someone who lives down the hall is smoking, you're still exposed to those pollutants. And we've done studies that specifically track air pollution within multifamily housing that shows it moves from one unit to another. How many people have lived in an apartment where you've smelled smoking or cooking from down the hall or in the building, right? So your nose is a very good environmental detector. So if you're smelling smoke, you are exposed to that group of compounds that are associated with secondhand smoke, such as a lot of different organic compounds, as well as the fine particles in the air. The smaller the particles, the more deeply they lodge in the lung and the more health effects that we tend to see associated with them. So given that we know all this about environmental exposures within housing, how do we intervene? So I like to frame this as the 3 Ps: people, places, and policies. Obviously, the first place you could focus your effort is on place. What is it about the building structure, the building design, the building maintenance that is affecting environmental exposures? The other 2 places you could intervene are with the occupants themselves by using directed education, case management, or clinical intervention. The other place you could intervene is in way of policies. I'm not talking about, I like to think of this as policies with a lowercase p. This isn't necessarily national policy on chemicals, but this is just what policies are in place to manage the site. Is there a smoke-free policy? What policies, what's the strategy for dealing with pest problems? We've worked closely with the Boston Housing Authority in Boston on better ways to control pest problems that involve less use of strong pesticides and more use of just of common sense on trying to understand what pests need to live. They need food, water, shelter, and access. And if you control those things, you don't necessarily need to dose a unit with a lot of strong pesticides that have health effects. Does that all make sense? Great. So what I'd like to spend most of my time today talking about is a project that focused on the greening of public housing. Can anyone tell me what I mean? What do I mean by a green home? What does that mean?
Efficiency in energy and avoidance of use of environmentally harmful chemicals.
Great. The term really comes from resource conservation, so being energy efficient, being resource efficient. More and more, we have folded in healthy attributes into what we mean by green housing. So people who are doing enlightened green housing nowadays are also looking at the healthfulness of the building. So using products and materials that don't emit a lot of chemicals into the environment. That's good for the health of the occupant. That's just an efficient way to build a building if you're focused on the health of the occupants. So it's really about energy conservation as well as environmental attributes. So before I dive into the study, I want to answer the question, why are we studying public and multifamily housing? This actually was initially motivated by asthma concerns about more than 15 years ago when we started doing this work. If you went to a particular housing site in Boston, a development, you might find that 25 or 30% of the children were diagnosed with asthma. That's just off the charts, like 3 times the statewide average for asthma prevalence. So there was definitely something very specific that was happening in these populations that was driving up the asthma prevalence rates. We started to we wanted to understand what was it about these homes that could be driving up this asthma rate. We looked for environmental factors, and we studied over a course of a few years, we studied a lot of different individual risk factors. We looked at allergens. So these are allergens associated with mouse infestation or cockroach infestation that children were sensitized to. We looked at combustion byproducts, the things coming from a gas stove. We looked at pesticides, smoking, ventilation, and in some cases, we looked at multiple exposures. For many of these outcomes, we saw elevated rates of exposure for the individual settings. The other reason, so even if these factors didn't cause someone to develop asthma, knowing that 25 or 30% of the kids have asthma was also a motivator. So we know that asthmatic children are more sensitive to environmental agents. So once again, we don't necessarily have the exact cause of what causes the development, but we can say something about what causes an exacerbation. So if you have asthma, what's going to trigger an asthma attack? And many of these things were suspected or there was some evidence that they could trigger asthma attacks. So that disease burden was a motivation, showing the inherent vulnerability of the populations living in these settings. Another motivator for working with public housing is the opportunity for intervention. The Boston Housing Authority is the largest landlord in the city of Boston. So we felt that if we could figure out what it was that was wrong with Boston public housing, we might be able to figure out what you could do to fix Boston public housing. And even though our studies might only enroll 100 or 200 individuals or families, likely a lot of people would benefit from that knowledge that would affect all of the households that are under the Boston Housing Authority in Boston. So whereas in the normal private housing market, you have to sort of work landlord by landlord, and you might have as many landlords as you have people living in those units. So it's a more difficult problem to sort of address. So this was part of our motivation. I just want to mention the Boston Housing Authority has been a great partner with several academic institutions in the city of Boston, our institution, as well as Tufts and Boston University. They've implemented smoke-free policies. In 2012, they were the largest housing authority in the country to go smoke-free before the rest of the nation went smoke-free. They've adopted, as I mentioned, better pest control practices that don't just focus on dosing units with strong chemicals. They've enacted resident education components, as well as trying to reduce chemical exposures. But today I'm just going to focus on green transitions. So we wanted to see what happens when families move from conventional public housing into newly built green and healthy public housing. And this was the study, we called it the BRIGHT study, the Boston Residential Investigation on Green and Healthy Transitions. Always good to have a catchy acronym. And this study was actually funded by the Department of Housing and Urban Development, and you can see some of our partners here. We focused on 3 different developments. 2 of them were new construction, where they were basically completely demolishing an old development and then relocating families who lived there temporarily for about a year, and then they would come back to live in the new development. For that, because of this relocation, most of these sites were redeveloped in stages. So they would have stage one, people would relocate either on-site or off-site for a year. They would build the new buildings and then they would come back, if that makes sense. The other property was actually a green renovation. So here's just the definition. We covered this a little bit, but what is a green building? Green building is the practice of creating structures and using processes that are environmentally responsible and resource efficient. So for aspects of the built environment, it has to do with siting, design, construction, operation, maintenance. In terms of consumption of utilities, energy, water, materials, natural resources. In terms of environmental outputs, waste, air pollution, water pollution, indoor pollution. So you can see there are certain elements here that are directly related to occupant health. You don't want to build a very modern, resource efficient unit, but have it be unhealthy. So this was, trying to make sure that we were really being thoughtful and holistic about this entire process. This gives you a sense of some of the green attributes of these three properties. So they had low or no VOC paints. So these are low emitting paints that aren't emitting volatile organic compounds, green label certified floor coverings, Energy Star exhaust fans, ventilation systems compliant with existing good standards. You can see some of this. So you should think about low emitting materials, very energy efficient appliances, and also proper ventilation. For many of these households, they didn't have adequate ventilation in the kitchen and the bathroom. There are two types of common ventilation in kitchens. People either have true exhaust fans, where when you turn on the fan, it moves the air from inside the building to outside the building. The other type is a recirculating fan, where when you turn the fan on, it blows air out. That's just sort of filtering the air in the room. How many people have a recirculating fan in their kitchen? One that just blows the air out into the room. I also do too. I rent but it is what it is. Those types of fans can get rid of smoke and soot and grease, but they don't necessarily get rid of a larger suite of air pollutants that may exist within the home. So ventilation was an important component here to make sure people had true, proper ventilation in kitchens and bathrooms. So here's an aerial view of this property called Old Colony in South Boston. This is basically at the end of phase one. So you can see most of Boston public housing, which is different than Providence. Providence has more of a mix. Boston public housing is usually 3 or 4 story brick walk-up buildings. So you can see the original buildings here, and these are the new buildings. You can see that they have solar arrays on some of the roofs, and some of these are townhouses, and some of these are in a mid-rise building. This site is actually one of the oldest housing authority properties in the city of Boston. It was built around 1940. This is really common for public housing to be built in the 40s, 50s, and 60s without adequate maintenance over the decades that have followed. This is a chronic problem within public housing nationwide in general. If you look at places like New York City, the New York City Housing Authority has capital needs in excess of $25 billion. In order to really modernize all their buildings, $25 billion. So we made a good investment in public housing originally, but we haven't necessarily kept up with that investment over the ensuing decades. This is what the site looked like an aerial view from the 40s. You can see it doesn't necessarily blend into the neighborhood. These are very different buildings. But this is sort of the nature of many public housing sites around the country. So what was interesting about this opportunity to study this transition is that we were basically studying a natural experiment. So the Boston Housing Authority was going to redevelop a site in stages. If you look at this line, on one side of the line, you have these new buildings that were built to be green and healthy. On the other side, you have the conventional housing. So one of the big confounders in trying to study the effect of housing is basically on the the nature of the occupants of the household as well as the nature of the neighborhood. So in this case, the populations that were going to occupy this side and that side were basically the same. These were all public housing residents. If you happen to live on this side, you were basically guaranteed a new apartment living on this side. The only thing you had to sign on for was a year of relocation. So the population was the same. And the other thing is the neighborhood was the same. So we think about outdoor variation in outdoor air pollution. These folks are basically living in the same neighborhood. So this natural experiment allowed a unique opportunity to really study the effect of housing itself without these common confounders. Does that make sense to folks? So once again, we're studying this movement from conventional to green. And if you think about these 3 Ps, people, places, and policies, this green transition involved all 3 of those. It involved we specifically had a resident education component. We were changing the buildings, and we were also changing policies. So all the new buildings had integrated pest management to manage pest problems, and all of the new buildings were going to be smoke-free. So our goal for the study was really to look at, well, what happens when you do all this to comfort, satisfaction, environmental exposures, health, and energy usage. So in picture form, this is what's going on between the conventional and the green. On the conventional side, when we started the study, smoking was allowed. You have gas stoves. You also have a lot of uncontrolled airflow. So these aren't very tight, energy efficient buildings, if that makes sense to you. On the green side, they were smoke-free, low-emitting materials, so they weren't contributing a lot of chemical exposure into the units. And the units were very tight, had tight building shells. So they were designed to be very energy efficient, but where they did provide airflow and fresh air was in the ventilation in the kitchen and the bathroom. So it's okay to make a building very tight. You just have to make sure that the building has an ability to breathe. And one way you give a building the ability to breathe is either install an HVAC system like you have in this room, or you put in air handling units like a kitchen fan that takes air from the kitchen and sends it out of the building, or a bathroom fan that takes air from the bathroom and sends it out of the building. If you don't send air from the bathroom outside of the building, you can build up moisture in a home and lead to mold problems and other things like that. With kitchen ventilation, you're eliminating a lot of the cooking related exposures, which can also produce particles that lodge deeply within your lung. So the first study we published looked at 2 common air pollutants. I know not a lot of people in this department do environmental health research, so I'll explain that. So this is PM 2.5. Maybe you've heard of this. So this is particulate matter smaller than 2.5 microns. What the hell does that mean? That just means they're very small particles that can go to the deepest level of the lungs, to your alveoli. Larger particles like PM10, bigger than 10 microns, are usually cleaned out by your upper airways. So these are the particles that get by that filtering system that we have in our upper airways. And NO2, nitrogen dioxide, is a product of combustion. So it's produced by cars, diesel trucks. Anytime you burn something, you're producing some NO2, and it's widely known to cause respiratory health issues. So the first thing we found is that PM 2.5 levels dropped by about 40%. And I should explain this graph. A green line is a family living in conventional in the first year and living in a green unit the second year. The black lines are living in conventional both years. So if you see green lines going down, that means an improvement from the green units. The NO2 levels in the homes went down by 66%. So the question is, what's driving this? What's driving the PM 2.5 likely is a smoke-free policy and proper ventilation within the homes. The NO2 levels are driven by just getting rid of a gas stove. I know people like cooking with gas, but gas stoves emit a lot of air pollutants into a home. And if you don't have ventilation, they can really be a problem. Asthmatics are especially sensitive to exposure from NO2. So if you have an asthmatic child, getting rid of a gas stove is actually a good step to reducing exposures that might trigger an asthma attack for the children, for that child. So pretty dramatic reductions in NO2. So this is a function of source control and building factors. The other thing, this is a nerdy side note. The whole talk is nerdy, but this is especially nerdy. There actually are, when you collect particles from the air, you can look at certain signatures on those particles. So if you look at sulfur content in particles that are in the air, it's usually a sign of particles of outdoor origin. There aren't very many particles that are produced indoors that have sulfur in them, but outdoor sources of air pollution have sulfur. What we noticed is the sulfur levels on the particles were only lower in the green units. So this showed that the buildings, so part of the reason for this reduction in PM 2.5 was the fact that the buildings themselves were so tight that they were acting as a filter to outdoor air. So once again, there are higher levels of air pollution on the street outside this building. This building captures some of those particles as the air moves from outdoors to indoors. There are filters in the HVAC system here which capture some of that. But in most homes, people don't have, in most urban homes in like Providence and Boston, you don't have heating, like active ventilation. Basically, the air just moves through any open crack and crevice. So these buildings were tight enough to filter that air. So that was an interesting discovery that we found with these studies. One thing I wanted to focus on is the fact that, within a 4-block radius, we saw pretty dramatic differences in indoor PM 2.5 levels. Most people think about environmental justice issues as being a function of neighborhood, a neighborhood that doesn't have voice, that can't control air pollution sources in their own neighborhoods. But there's actually an environmental justice story to be told related to housing. So PM 2.5 levels were much higher in homes that allowed smoking. So it might not be what you're doing, but it could be what's happening down the hall. You're exposed to to those particles that are moving from unit to unit. Also, if it was a green building, as I said, these had both all the aspects of people, places, and policies in place to lower levels of PM 2.5. There was also a tightening up of the error bounds around cooking. So cooking was also another factor that contributed to PM 2.5 levels. So to summarize, like why we think we saw reductions, it's really this combination. If you reduce indoor air pollution sources and you reduce the infiltration of outdoor air, you result in reduced exposure to air pollution. So kill the sources that are happening in this room and stop pollution from outside coming in. That will lower the levels that you see in this room. And if this room is your home, you're going to be exposed to a lot lower levels of air pollution because most people spend a lot of time at home and they're exposed during the day and overnight. We looked at environmental exposures like inadequate ventilation, chemical exposure, mold, secondhand smoke, pests, combustion byproducts. For most of these, you can see pretty dramatic reductions. I should note the chemical exposure here is not measured chemical exposure, but we were asking people about how often they use things like air fresheners and pesticides. So not as big a reduction in terms of like the behaviors associated with that, but pretty dramatic reductions in mold and pests. This is not surprising. These are new buildings. You don't expect them to have mold problems and pest problems. But what we've tried to do is put all these observations together into a coherent story about what is driving potential improvements in health. So the next paper we studied was focused on health benefits. This was published in the American Journal of Public Health a few years ago. One of the things we asked about were symptoms at home in the last 30 days. How many people have heard of sick building syndrome? So that was a problem that sort of arose in the 80s. After in the 70s, we tightened up buildings because of the original energy crisis in the mid 70s. So people started to experience these symptoms associated with sick buildings. So what we did is we asked people about symptoms like sore or dry throat, burning, itching eyes, sneezing attacks, wheezing, and we looked at the difference between green and control. So most of these basically trended in the right direction, and the ones that are in bold here were statistically significant. So on the green side, we saw fewer symptoms for the adults. If you take those symptoms and create a summary score, like what's the average number of symptoms you have in the last 30 days, we had basically three groups of people who lived in conventional housing in both years, people who lived in green housing in both years, and then the people who moved from conventional to green. The only place where we saw statistically significant differences in symptom scores were the folks who moved from conventional to green. So people who moved from bad housing to good housing had statistically significant reductions in the symptoms that they were reporting over the last 30 days. That's one measure of health. The other measure of health we were concerned about was asthma morbidity. I told you that's part of the reason we started to study public housing was really because of asthma prevalence in public housing. So here, we didn't enroll people based on whether they had asthma, but since it's public housing, a lot of people did have asthma. So we looked at what was happening for the children and the adults living in the units. For both groups, we saw, in general, there's some noise in the data. We saw generally reductions in outcomes, so improvements in outcomes going from the conventional to the green. The only group that was statistically significant, however, was the children. So for the adults, we saw basically, it looked like things were getting better, but it wasn't statistically significant. For the kids, many of these outcomes were statistically significant. Missed school day for asthma, hospital visits, asthma attack. If you put it in terms of an odds ratio, so here we put it in terms of, if you're living on the conventional side, what are the increased odds of having one of these outcomes you experience? So these odds ratios are pretty dramatic. They range from basically 3 to almost 5. So if you're living on the control side, you're almost 3 times more likely to have asthma symptoms than living on the green side. You're almost 3.2 times more likely to have an asthma attack. You're almost 4 times as likely to have a hospital visit. So these were pretty dramatic improvements, but they were consistent what we thought could happen. You never know when you put a big intervention like this together. Some things could go in the opposite direction. If you tighten up buildings, there was a chance that that was going to increase people's exposure to indoor air pollution. We didn't really know until we actually conducted the study. I'm going to skip that. The other thing we looked at was utility costs. So these were very old energy efficient buildings. With the new construction of these first 150 units, there were significant savings on electricity, gas, and water. That, just for the first 150 units, this turned into almost $600,000 a year in savings. So if you want to make an economic argument for this, if you don't care about kids with asthma, and I want to know why you don't care about kids with asthma, but if you don't care about that, if you want to just count the dollars, if you monetize these health improvements and then add that number to saving $600,000 a year, it doesn't necessarily justify the significant cost of new construction. New construction is extremely expensive, but it definitely shows that you're saving you're achieving some money, some savings from these improvements. So we tried to put this all together into what we call the new green balance sheet. So we saw that indoor air quality improved for NO2 and PM2.5. We saw pretty dramatic improvements in health. We saw savings in terms of utilities and work orders to a significant tune. Some of the unexpected results, we saw some reports of discomfort. In most cases, how many people have ever lived in a overheated apartment, like in the winter, right? So it's really common in the Northeast. Most heating systems are oversized, especially if you have a steam system. Those are categorically oversized. So for the folks moving from the old housing into the new housing, their old housing was overheated. If you bring that temperature down to what it should be, some people report being cold because they got used to living in an overheated apartment and walking around with a t-shirt and shorts. What we found is that after about a year, this kind of subsided, that people got used to the new temperature. It wasn't that they were cold, it was just cold in comparison to what people had gotten used to. And we saw some reports of spot heating, which we didn't really want people to do, like portable plug-in heaters. Those can be dangerous. We don't want people using those. We actually saw some increased sleep duration as well. I should say, one of the things we created was this guide called Welcome Home, Keeping It Green and Healthy. So every family that moved into one of these new units got this brochure. I shouldn't say this since I work at a school of public health, but sometimes educational materials I'm not a big fan of because I don't think they necessarily hit home. They're not, people don't necessarily use them. People don't necessarily read them. They're not a motivator for a lot of people. For this, in this setting, we thought if people are moving into a brand new unit, some of these educational materials might be motivating. Like, here's a guide to keeping your home, like, it's beautiful, green, and healthy today. Here's a guide to keeping it beautiful, green, and healthy for the long term. And so we worked with the Mass College of Art and Design on preparing these. I'm going to skip that. So back to the big picture. People, places, and policies matter. Indoor sources and indoor exposure to outdoor sources matter. Structure and systems matter. Operations and maintenance. We probably still need more research on the full balance sheet. You know, what does this mean for the, I wouldn't be surprised if there are improvements in educational outcomes for the kids who moved into the new units. We just didn't have the funding to sort of track that. Healthy conditions need to be maintained. One thing I didn't mention on the green side, about 6 months into the new development, they actually started to have a mouse problem, and they called us in to give, and sort of enlist families into knowing what they need to do to prevent pest problems, specifically mouse infestations, and that subsided. But that was, you have to really keep on this. Just building a green building doesn't mean it's going to be green forever. You have to make sure that it's maintained. So in my last 5 minutes or so, I want to talk about where this work has moved since. We were funded, we had a collaborative study with between Harvard and Boston University that lasted for about 5 years called CRESH, Center for Research in Environmental and Social Stressors in Housing Across the Life course. It's a mouthful. And we really were fascinated by whether we could get additional insights in terms of what people were exposed to in their homes if we measured air pollution in real time in their homes. And so there more and more, you might see some of these things advertised on TV or available on Amazon. You can buy a low-cost sensor to measure air pollution in your home. So some of these sensors, a lot of them are crap, pardon my French, but they're getting better and better. And so they were getting to the point where we thought they were ready to be used for studies. So we actually used some of these low-cost sensors in a sensor platform that we deployed into people's homes, measuring pollutants like PM 2.5 and NO2. When you do that, you get signals like this. These spikes are actually showing NO2 spikes associated with using a gas stove in your home. So gas stoves, and remember, I don't know if I mentioned this, NO2 is regulated as an outdoor air pollutant. So every city, every region has to produce a report to a plan to the federal government showing how they're going to keep their city, their region in compliance with outdoor air standards. That includes nitrogen dioxide and PM 2.5, the two pollutants we studied. You can see really high levels of NO2 in someone's kitchen that is completely hidden from any of these environmental monitors that the EPA puts around the country, and that's where people are breathing and spending time. So it really is a hidden issue. What we've done recently is taken these real-time measurements of PM 2.5 and try to understand the relative contribution of indoor sources. I won't unpack this fully, but basically this is showing what the red bar shows the proportion of the pollution that's coming from indoor sources. The gray is from outdoors. If you look at the effects on the mean level in a home, almost 90% is actually coming from what's happening indoors in the homes that we studied. And this was, for this study, this was in an urban cohort in the city of Chelsea, adjacent to Boston, a lower income population in general. If you look at what's affecting the 95th percentile, it gets even higher. So what's affecting those giant peaks that you see in a home? Those giant peaks are definitely being driven by what's happening inside the home. If someone's lighting a cigarette, lighting a candle, burning incense, burning dinner, anything that they're doing to affect air pollution levels in the home. So we have tons of this data that we're just in the process of unraveling right now. I'd be happy to share the papers that have resulted from any of these studies if people just shoot me an email. It takes a village, so a lot of people, so many people to thank who have been involved in either the lab work or the work out in the field to make these studies happen. Always good to thank your funders, without whom we couldn't do any of this work. Happy to take any questions now or by email. I know that was a lot. Yeah.
Great talk. It was fantastic to hear. I have a question mostly on how the funding for rehabbing Boston Public Housing, where did that come from? What's the chances that this is going to happen in other authority developments?
So the sad truth is the road to redeveloped new construction is a long and grim road right now. So people, if you ask people, do they in the federal government, if they believe in public housing, they'll say, we believe in public housing. Are you going to build more of it? No one's planning to build more of it. There are programs within the Department of Housing and Urban Development that are designed to renovate properties. So that has been growing in the last 5 years. So, and I would say, in terms of being efficient with your dollars, that's probably the way to go. We know that you can't afford to build new construction. The funding for the specific properties that were redeveloped in Boston came from a mix of federal dollars, so like line item HUD funding going to the regions to build new construction, and then public-private partnerships. So this site, the main site that we studied, is actually privately managed. I'm a big fan. I always want the housing authority to be the entity in charge. I trust that. But in terms of managing the day-to-day of housing, I'm okay with a private entity managing that as long as they have housing authority oversight. So it was like a combination. The short answer is a combination of tax credits, direct funding, and private money that came in because it was a very good construction deal at this time. And a lot of these decisions were made at the tail end of the last recession. So construction companies that weren't normally in the business of building low-income housing were suddenly in the business of building low-income housing because the market was so dry.
Got it.
Does that make sense?
Yeah, and I'm curious to think about the other parts of the subsidized housing market in the US. Do we think indoor air quality and lots of these indicators are similar in privately owned housing, or do we think they're even worse because there's less oversight?
So this is the thing. I definitely don't. It's a great question. We're actually, I'm involved in another study where we're using national data to partially answer that question. If you look at national data, if you take the equivalent population, so the folks who would be eligible for public housing but are living in the private market, actually their environmental exposures are probably just as high. So even though I have focused on public housing, part of the motivation is this is housing we could potentially fix because we have a single landlord covering a lot of people. I don't want to give you the impression that that somehow it's only there. But part of the reason you have these longstanding issues in public housing is the fact that there hasn't been operating funding at a proper level over years, over decades. So they haven't been able to modernize and address these issues. There are developments we work in that have been chronically infested with cockroaches for like 40 years, right? That is a problem that could have been solved 30 years ago. Yeah.
Great talk, thank you. I was sort of piggybacking on Will's. I was thinking about the scalability and impacts for like renovation versus like a full demo. Are there environmental impacts to like raising these buildings, and whereas like the equipoise around doing that, or you think that it's bad shape, reno rehab not possible. And then part two is if like going the reno rehab route, are there specific like, things you would focus on based on your work, like smoking cessation or the ventilation?
Yeah, so I definitely believe we haven't had the opportunity, we haven't had the same natural experiment provided to us to do the study of renovation. If someone gave me the choice of which one I wanted to study, I would have studied green renovation rather than green new construction, because I do think there are environmental costs associated with demolishing 800 units of housing and building new. Definitely, you get closer to a cost-benefit equation that looks promising if you're renovating efficiently to some of these healthy and green standards. Definitely, these policies apply across the board. You know, integrated pest management is the way to go. Cities like New York and Boston are using them. They really do lower people's exposure to some very toxic pesticides. We were just talking earlier about, you know, we've gone into units, we wipe the kitchen floor, and you can see pesticides on people's kitchen floors that were banned 30 years ago. So these pesticides you don't just turn on the ventilation and they go away. So smoke-free, better pest control, all those are good things. Definitely increased ventilation, putting in ventilation that exhausts the outside is something I would prioritize, which is something you can do in many cases if you're doing a full like kitchen and bathroom rehab. But still, that's expensive and you have to weigh it against the cost, weigh it against the benefits that you expect. Have I answered your question?
Yeah, I made me think of one more thing.
Yeah.
How much of this translates to schools, public schools?
Well, so the thing that's different with schools is that you don't have the diversity in sources happening. Like homes are more complicated than schools, so in terms of sources, right? So in a home, you have all of the cleaning materials, what's coming from the carpet, you have cooking, personal care products, smoking, incense, candles, everything, Schools are a little simpler in terms of the likely sources that are present in those spaces. Having said that, I'm just about to submit a paper where we looked at a very large school district, we're not allowed to say which one, for whether they have proper ventilation, and we use carbon dioxide as a marker of that. More than half of the classrooms don't have proper ventilation. So in the age of COVID, suddenly people got very interested in ventilation. Like, do you have enough fresh air coming into a space? So I normally look at it in terms of environmental exposures, but if you add the COVID risk, schools have a ventilation problem. They don't necessarily have a source problem, like a chemical source. Many schools are located where they shouldn't be. They're close to major roads. They're in dense urban areas. So it's good to have, they can be getting their exposure from outdoors, which makes the ventilation story a little more complicated. So if you have a lot of indoor sources and you ventilate, you're getting rid of the bad stuff. If you're in a very polluted neighborhood and you ventilate, you can be bringing some of the bad stuff in. I know that's not a very satisfying answer, but it's complicated.
I think we have time for one more question.
Got it.
Not all of them.
I think there's also a large class, maybe
Oh, okay.
lingering out in the hallway.
About to swarm. Okay.
Thank you. Oh, we didn't even check the Zoom.
Oh, we should.
I guess that there are some things in the chat. Sorry.
Oh, no, in terms of
Oh,
how
Ellen's phone.
disgusting it was. Yeah.
Hi, Ellen.
Like Hartford is really,
Good, good.
really bad. Like stuff that was, yeah, literally falling apart.
What is it?
Unless it is. bring pain. Why don't we get that? Okay, so we're
So do
gonna
we
go
have to
right.
shut?
Anyway, sorry.
Yeah, you're fine.
I'll give you a comfy chair.